Geometric sequences and series. We're going to only study two specific ones of the sequences and series, and that's arithmetic and geometric. There are tons and tons and tons and tons and tons more. If you're going to take the 3-semester calculus, 231, you will spend a third of the semester studying them, the different types of sequences that exist. And if you're going into engineering, you're going to run into them all over the place. Math, not so much. Okay, so here we go. Geometric series or sequences are of the form 2, 4, 8, 16, 1, 3, 9, 27. The hallmark is that you move from one position to the next by multiplying by the same number. Here I multiplied by 2, multiplied by 2, multiplied by 2. So to get from one position to the next, I multiplied by 2 each time. Here I'm multiplying by what number? 3. So multiply by 3, multiply by 3, multiply by 3. The hallmark of a geometric sequence is that you are multiplying by the same thing each time. That quantity is called the common ratio. And we normally call it R for common ratio. The common ratio R. Ratio always means fraction. Ratio is a fraction. The common ratio actually is a fraction. And what kind of fraction is it? Well, the common ratio is you take two terms that are side by side. Remember, last time with the arithmetic, we took two side by side and subtracted. So it was a sub k plus 1 minus a sub k to figure out how you got there, right? Same thing's going to be true here, but what is the reverse of multiplication? Division. So I'm going to divide two terms. I'm going to take a sub k plus 1 and divide it by a sub k. That's how I'm going to get R. So in this case, I could take 3 and 9. R would be 9 divided by 3, which is 3. Here I could take 8 and 16. 16 divided by 8 is 2. So that tells you I'm multiplying by 2 each time, and that's what R is here. That's what R is here. And this one tells me I'm multiplying by 3 each time. So common ratio is a fraction. Formulas for the geometric sequence, and that's on your formula sheet as well. A sub n is A, and like I said, I always call this A sub 1. A is always the first term, times R, the common ratio to the n minus 1. R can't be 0. 0 to a power doesn't make any sense, because it's always 0. Where R is a sub k plus 1 divided by a sub k. So we're going to do the same thing that we did yesterday, only now it's going to be with the geometric, and it says find the common ratio R and write out the first 4 terms. So I look at this, and the first 4 terms is b sub 1 is 5 halves to the 1. B sub 2 is 5 halves to the 2. So this is 5 halves. This is 25 fourths. B sub 3 is 5 halves cubed. That's 125 over 8. B sub 4 is 5 halves to the fourth, which is 625 over 16. So the first four terms are 5 halves, 25 fourths, 125 over 8, 625 over 16. What's R? What's R? 5 over 2. And if you take a look at it, isn't that what's being raised to the power? If I know that the general form is A1 R to the n minus 1, R is the guy being raised to the power. And in this case, A1 is 1, and what's being raised to the power is 5 halves. Now this one's a lot harder because we have two different exponents. So first four terms and R. So U sub 1 is 2 to the 1 over 3 to the 1 minus 1. Well, this is just 2. U sub 2 is 2 to the 2 over 3 to the 2 minus 1. That's 4 over 3. U sub 3 is 2 to the 3 over 2 to the 3, or 3 to the 3, too many 3's, minus 1, which is 8 over 9. U sub 4 is 2 to the 4 over 3 to the 4 minus 1, which is 16 over 27. What am I multiplying by each time? 2/3. 2/3. 2/3. 2/3. 2/3. So this says my first four terms are 2 4/3, 8/9, 16 over 27 with an R of 2/3. Now if I wanted to write this, and you're not going to like this, and you can ignore me if you like, into that proper form, have these two exponents be the same. If I'm looking at 2 to the n, 2 to the n is 2 times 2 to what power? What did I pull away? How many 2's? 2 to the 1? So if I have to multiply these two together to get 2 to the n, what is the power on this 2? N minus 1. Because if the bases are the same, you add the exponents, that becomes 2 to the n. Well, then this becomes then 2 to the 2n minus 1 over 3 to the n minus 1. Now, if you notice, the exponents here are the same. There's your 2/3. So this is 2 times 2/3 to the n minus 1. Now that's in proper form. That's why it was harder just to say, what is my multiplier? because these two things had different exponents. One was an n, one was an n minus 1. Now they have the same. I can write it in the format, and you can see, indeed, what's being raised to the power is 2/3. Cool, huh? As usual, only to me.